Today's video is on fundamental counting principle and permutations. So this unit is on probability and a lot of counting techniques. What we're going to do is we're just going to start out with a very easy question. It says TGI Fridays has a deal where you can order an appetizer, entree, and dessert for a low price. There are 7 appetizers, 13 entrees, and 2 different desserts. How many weeks will it take Matilda to eat every different meal if she chooses one a day, every day? So basically, this is a simple multiplication problem. You have 7 possible appetizers times you have 13 possible entrees times 2 different desserts. And all you have to do is multiply every single one of those and you will have 182 meals. But the question says, how many weeks will it take? Well, if there's 7 days in a week, you're going to find out that it's going to take 26 weeks. So half a year to eat every possible combination. So that sounds like quite a bit of food to eat from TGI Fridays, but hey, if that's what Matilda wants to do, that's what she needs to do. So the fundamental counting principle: if one event can occur m ways, the other events can happen n and p ways. What is the number of ways that all events can occur? Just like the problem above, you just have to multiply. So it would be m times n times p. Okay? And of course it can go on if you had more. So the next example talks about characters of a password. Again, it's the same kind of problem, except for now we have 5 different characters. Now, there are some stipulations. It says that the first entry must be a letter. Well, we know that there are 26 letters in the alphabet. And it says the last must be a number. So this last character must be a number. Well, think about numbers. Individual digits are 0 through 9. So that means we have 10 possibilities for numbers. Now, in between, any combination is possible. Now, this doesn't say that there must be specific capital letters or lowercase letters. So, for this problem, we're just going to assume it could be a letter or a number, which gives us 36 possibilities per. And we'll just say a letter or a number, a letter or a number, and a letter or a number. Now, eventually we'll get more specific when we talk about capital letters and lowercase letters. Okay? So after you multiply all that together in your calculator, you're going to find out that if you are allowed to follow these, or must follow these instructions, you have over 12 million possibilities when you have those very loose restrictions on a password. You have, obviously, if we were to go to capital letters and lowercase letters, we're talking about 62 different possibilities for the middle, and most passwords, as you know, for certain accounts need 6 characters. You can have numbers, capital letters, lowercase letters, so then you're going to get even bigger. So yes, that's why passwords are usually pretty secure unless you choose a bad one. So we have a couple of definitions. Permutations. Permutation is an ordering of objects where the number of permutations of R objects taken from the n distinct objects is denoted by NPR. I know, that just drove you nuts. When you see it in action, it's going to make a lot more sense. And then we have factorial. Now, factorial is the product of natural numbers up to n. So basically what that means very simply is if we had 5 factorial, that means you are going to do all real numbers multiplied up to 5. So 1 times 2 times 3 times 4 times 5 is what 5 factorial means. Now, why don't we just write it that way? Well, what happens if you have to do 17 factorial? Don't worry, your calculator is slick enough that it can do it for you. So let's do an example of one of those. So we have 8 horses are in a race at the Kentucky Derby. How many different ways can the horses finish the race? Assume there are no ties. Well, this is a perfect example of where you would use factorial. So we have 8 factorial. Why? Well, while they're racing, you have 8 choices for the first horse to come in first place. But once that first place guy finishes, there are only 7 horses left in the race, so there are only 7 horses racing to find a second place position. And then we keep on going and going and going all the way down to 1, or as we have just said, 8 factorial, which you just use your calculator. Let me show you how. So you type 8, then you press the math button, and you slide over to number, slide over again to CPX, slide over again to PRB, which is probability, and then you go down to number 4, which is your factorial symbol. Now, math sliding over to PRB is going to be very popular for this unit. You will use that quite a bit. So we just click number 4 or click enter while it's highlighted, press enter, and we're going to find out that when 8 horses race, there are 40,320 different ways those horses can finish. That's why, well, they have a whole bunch of gambling on horses, because your chances of predicting what's going to happen aren't always very good. Now, let's get more specific. How many different ways can horses finish first, second, and third place? Well, that would go back to something like this, where, again, I just said you have 8 horses that can finish in first. After that first horse finishes, there are only 7 horses racing for second place, and then only 6 horses are racing for third place. So 8 times 7 times 6 is going to give you your answer. But, as I mentioned in the definition of permutation, you have 8 horses racing. How many different ways can they finish in the first 3 places? So I want to show you the shortcut with your calculator, where you can just take your calculator and you would do 8, and then you go back to that math button, slide over to probability, and look at number 2. It's NPR. So we're going to do 8 permutate 3. Click enter, and you will get the exact same answer as if you were to do 8 times 7 times 6. Now, for that example, again, I understand you could probably just type 8 times 7 times 6 in the calculator quicker, but what happens if you were doing 142 permutate 13? That would be a lot of work to do. So this is a shortcut for certain problems. So we have 336 different ways that they can finish in first, second, and third. Okay, again, going back to horse racing, that's why odds are not that good. So we're going to look at permutation of n objects taken at R at a time. So the number of permutations of R objects can be taken from a group of n objects is denoted by NPR again. We just talked about that. So now we're going to do the horse example again, but now we're going to do it with books. So to make this shorter, and wait till you see how big the numbers are, it's going to be, we have 12 books from a summer reading list. How many different ways can you read 6 books? Now with this, the order in which you read the book changes things up a little bit. So we're just going to say you have 12 books to choose from. How many different ways can we permutate 6 different books? You take your calculator and you would just say 12, math, slide over to probability number 2, and then we're going to choose 6 books, click enter, and if you just want to read 6 books out of 12, you have 665,280 different ways you can read those books. Okay? So then we have 8 books. That would be 12 permutate 8, which is going to give you over 19 million. It's going to be 19,958,400. I'm going to let you do C and D on your own. Just practice using your calculator. And let's see if you got it right. All you had to do is use your calculator and you would come up with those numbers. Look at how many different ways you can read 12 books. 479 million and more. That's quite a bit of different ways that you can read 12 different books. So ordering with repetition. So far we've had events where there's no repetition. So all objects have been distinct. So if some objects are repeated, then some of the permutations are not distinguishable. Okay, so look at 6 different ways we can use the letters to spell pop. So we have, if we just use one capital letter to distinguish between the 2 different P's, then we have POP with a capital P first. Then we also have POP with the capital P last. We have OPP with a middle P being capital, and then the last one being capital. And then we have PPO, where the first one is capital, and another one where the second one is capital. So it looks like you have 6 different ways to spell pop. But if we are not going to consider capital letters, then how many ways do you actually have to rearrange the word pop? You only have 3, because you have POP, OPP, and PPO, where we don't distinguish the different cases of the letters. So permutations with repetition has another formula where all you have to do is take the total number possible and divide it by the repeats factorial. So for example, you have Mississippi, and we're going to figure out how many times we could find the number of distinguishable permutations of the letters Mississippi. So that means if we have the first S and the second S switched, it's not going to matter. It's still going to spell Mississippi. So how many ways can we just jumble all those letters together? First, you have to count. There are 11 letters in Mississippi, so we have 11 factorial. So we have 11 opportunities for the first letter, 10 opportunities for the second letter, all the way on down the road. 11 times 10 times 9, yada, 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 is 11 factorial. Over now the repeated letters. So let's look. How many letters actually are used to spell Mississippi? We have an M. There's only one of them. We have the letter I. There's 4 I's. We have the letter S. There's 4 S's. And then we have the letter P. There are 2 P's. So with the repeated letters, we need to put those in the denominator. So we have 4 repeats for the letter I. We have 4 repeats for the letter S. And we have 2 repeats for the letter P. So what we're going to do is we are going to find 4 factorial, 11 factorial, and 2 factorial. Well, we know 4 factorial is 4 times 3 times 2 times 1. So 4 factorial is 24. 24. 2 factorial is just 2 times 1, so it's 2. And 11 factorial on the top is a huge number. We are going to have that many. 39 million and change. Almost 40 million. So what you do in the calculator is you just type this big old number divided by 24 times 24 times 2. And that's going to give you a grand total of 34,650 different ways you can rearrange the letters of Mississippi if the first S is treated the same way as the second S and third and fourth S, where the S's repeats don't matter. Okay? Otherwise, if these were 11 different letters, we would have 39 million ways to rearrange them. But since we have repeats, there's only 34,650. Alrighty? So that's that. Here's a lesson on, again, this is the fundamental counting principle and permutations. Your next lesson is going to be on what's known as combinations. Okay? So, that's it. This is Longo. I'm out. See you. Bye.